This conference will now be recorded. This
Okay,
conference will
continue.
now be recorded.
Today, I would like to complete the remaining programs which we have left behind yesterday. What I suggest is be patient. Definitely, you will get the best, the information available in Python. It's not like we are going to miss out anything. But I'm going in an order so that your foundation is good and strong. That's what I'm looking for first. Because later on, I'll make you to work many programs again on collections, all this stuff. Work with that, having a good understanding of loops and this basic stuff is important. Otherwise, you struggle again. If I should cover only the topic, then it's a different thing. Okay, we can by now we would have finished half of the Python. That's not the point here. Okay, so and I told you right, we are going to have a detailed discussion about core and advanced as well as analytical. Core and advanced, you will be having complete discussion here in this, as for offline. Analytical will be only we will be doing online, so you can also join that. That's not a problem at all. Okay, so shall we start our programs now? I hope yesterday you have a better understanding, right? How many of you are new to this coding? May just or at least how many of you are able to improve a bit from your previous this thing? Because I'm very hardly I see a couple of people here, right? So if you are new, so do you found that it's easy to improve there? And if you already know that, of course, it's a different story. You need to get some better topics that will come. We don't need to worry about it. My point is someone who don't know anything, but still, if you are able to improve yourself, is that helping or not? That is the point. So that is what I am looking for. People who don't have any idea, but still you are able to see that difference, then we are going in a right direction. And if you are not seeing the difference, means you can tell me, not an issue, because it's not like we don't get it. This is not something too difficult. I don't want to use the word rocket science because that is what I don't know about rocket science, so I don't want to tell about. But you got it right. If you want, I can make you comfortable because I had started training, for very basic people, beginners initially, for 14 years back. So I know how to get to that level, the very beginner level also. You got it right. So that's the point. So let me start it. Today's program is this. We are moving to the next style of coding. So far we have done one style of programming. What is that style? Looping, putting some if in that, checking some condition, and then what is that? And we were doing some this prime or composite, this kind of coding. Yes, right. But now today this looping, same looping, but a different style of coding again. Many people don't know to improve your logical skills. There are some fundamental logics you need to learn. Trust me, if you are really good with the sum of sum of first n numbers. 1 minute, guys. I think here the people are coming. Sorry for the noise. The very basic logics are most of the time when you are working with programming. These logics keeps coming even in the most advanced level of coding. When you are doing your day-to-day projects, also the sum of n numbers, factorial, product of numbers. Okay, that counting something, doing sum of digits. All this keeps coming into your day-to-day tasks also. These are very core logics, which are very helpful to you again and again in your further coding. In project, what I am talking to tell is, got it right there. So next, this is the one, printing digit by digit. You have 256. You have to print this digit by digit. How you are going to do that is the point. It's a simple one. So why don't we start doing this? It's a simple one. Printing digit by digit. So I'm explaining the logic here. See here now. uh, some of our students suggested Note Edit Plus, but somehow that is not working here to friends. I'm using Notepad now. I know Edit Plus is good for us. Should excuse me if I am not using that. Now coming to this now, you can take any number, 3 digit, 4 digit, 5 digit. Usually 3 digit is good for analysis. We'll take a 3 digit number and print digit by digit. You can take anything of your choice like 1, 2, 3. It's not like 256 or 356. A number is your choice. Okay. I should print digit by digit. Digit by digit in sense might be you can say 1, 2, 3 is one kind of printing like this. 1, 2, 3. But for now, we are not going to print 1, 2, 3. We print 3 to 1. What do we do? 3 to 1. And if you ask me, sir, that is also digit by digit printing, right, sir? Yes, definitely. But if I should do that, prior to that, you should understand first how to extract that approach of extracting digits from the given number. Understood? So you can leave this aside for now, but I'll make it work this also. But the logic which we are going to do it right now will extract a digit from the right side. Means right side in sense first it will extract 3, after 2, after 1. Now I do have idea how to extract from beginning also 1, 2, 3 also. But if I straight away do that, you get confused. You don't have idea, some of you at least. So first let me make you comfortable. Later on I will make you to extract digit by digit again from the beginning also. Both approaches will do. This session only. Are you following this now? So what do you do to extract a digit from the rightmost digit from the given number in coding? These are all fundamentals of logics. What is that? Basic. Because when you know all this, then automatically at least you will come to some level of programming. Trust me. Got it right? And many people don't have this idea. That is the problem. Whenever you have such kind of requirement, simple tip is divide it by 10. If you want just one digit to extract from the right side, divide by how much? 10. It is a tip. Understood? There are certain tips to implement certain things. For coding also, if you just remember these kind of tips, it's not difficult at all. So the first thing you have to keep in mind is if you want to extract a rightmost digit from the given number, what you have to do? What you should do, gentlemen? Divide by 10. What you should do? So the tip here is divide by 10. So how do you do it? Let me just show you. First, it's just all of you know this. All of you know how to do divide, how to do division by 10. How do you do? First, you take 10. How many times it will do integer division here? Don't do decimal division. Okay. 10, how many times it will go, gentlemen? If it is integer, no fraction. 10 12s. How much, my dear friends? You can answer in the chat, my dear online friends. What is the reminder? I think you are looking for this, right? Are you looking for this or not? This is what you want to get. If you observe carefully, when you do this division, you get remainder as what you are expecting, the rightmost digit. Suppose from this digit, I extracted the rightmost part, that is 3. I extracted the rightmost digit. And what is my next input? 12. Rest of the digit has to be input after extracting 3. What is the rest of the digit? 12. See, I am clearly, slowly explaining this. You just listen. This is not something very difficult. So what 12 should be input for next iteration. Initially 123 is input for iteration. This is looping. This goes in loop. Understood? Now, if I want 3, what should I do now? You take a 3 is a reminder, right? Yes or no? Which operation should I do if I should get reminder? Assume that this is some n, okay? Assume this value is n. So what should I do now? R equal to n percent delta. Means what I get here? I get 3 here. Okay, I got what I want to extract. Still one more step is there. That is incrementation. So far we have done I equal to I plus 1, I equal to I minus 1. That is normal incrementation. And incrementation can comes in different forms, not just that too. So far we have used condition like I less than or equal to 10, I greater than or equal to 10, something like this. Here also condition might be a bit similar, but the way we increment is a bit different. I hope you are following, right? So what is my input for next iteration? Tell me. 12. Now if I see 12 is there in this year. Am I right or wrong? This division here, 12 is a quotient. Yes or no? So what do you do then? So you have to, what you should do is you have to take this n as a quotient. If it should be, and you have to keep that in n itself. You can keep reminder in some variable, no problem. But that quotient, you have to keep it to the same variable, same input variable, because that should be input for next iteration. You are getting this point, right? So you get quotient. How to get quotient? N slash 10. Should I use the double slash or single slash? Double slash, integer division, right? This is Python. In Python, if you want to do integer division, you should use which one? Double slash. Might be you forget. I didn't forget. I taught this in operators topic. Yes or no? So, in which variable should I put it in X? If you put in variable X, you miss the continuity. This is actually incrementation variable. You have to increment this n. Same, you have to keep this input 12 into the same n. If I should put it into the same n, what should I do now? I have to initialize to n itself, not to any other extra variable. Are you following?
Sir, but you told we can't write the same variable twice in the same code.
I didn't write twice. I wrote it only for one time.
Over here we're calling n 123 in the starting, and then we're calling n is equal to 12 by the ending.
Redeclaration is not allowed. Okay, but in Python you don't have such issue. Okay, because as you don't have a data type, it will be overwritten. So you have to take care of it. Nothing to worry. Okay. So do you understand this? You get this point? What should I do? Again, this quotient I have to store into the same n. You got the point or not? Why should I preserve this n itself? Because that is again input for next iteration. Again same story continues. Same again divide n again one more time. So you have to do this until your n becomes 0. Until what? N becomes 0. N greater than 0. Means until n is greater than 0, this loop should keep repeating, this while loop. Once n becomes 0, you should stop this process. From first iteration, we understood one thing. We extracted 3. You got the point or not? Again, this iteration continues. Is 12 greater than 0? True or false? Just follow me. You don't need to do anything if you are new to this kind of logic. True or false? Then again same story. Again do the remainder operation. R equal to n percentile 10. This time divide 12 by 10. How many times 10 divides 12? 1. That is quotient. 10 ones are 10. Remainder how much? You extracted 2 second time. If you observe carefully, slowly you are getting the process. So what you do? Again, same operation. Now I have 12 as my input. Divide by 10. It goes for how many times? 10 ones are 10. Okay. So remainder is what? So 10 ones are 10. Remainder is obviously when we do this 2 is automatically stored to this R. It is assigned to R. You don't need to do anything. Now what is my next input? 1. If I should get 1, what should I do? I should say quotient, right? Quotient means n double slash 10. What do I get? I get 1. Again, this should be input for next iteration. And where should I store it? Into the same n. Are you following this or not? So n equal to n double slash 10. What is there n now? 1. This time what n has? 1. R has 2. If you observe, I have extracted 2 digits. One is 3, other one is 2. Again, same story continues. Iteration 3. If you have 3 digits in your number, 3 iterations are performed. If you have 4 digits, 4 iterations are done. If it is having 10 digits, 10 iterations are performed. So how many iterations are done here depends on the length of the digit. You got the point, right? Suppose digit has n digits, n iteration happens. Are you following this or not? So that's the idea about this process. So are you ready to write this code now? This is a when you write it, you just have just 3 lines of code. You know why I am taking time on this logic is the next 10 programs or 10 to 15 programs which we work right now depends on this logic. And if you understand this carefully, rest of the coming logics are easy for you. And if you have issue here itself, the other logics are difficult, or at least you get a bit tough there. But if you understand, you can play with them. It's like, cakewalk. Clear, right? So, iteration 3. It's like there is a bit of power fluctuation here. Huh? It's okay, fine, not an issue. Step 3, again, is n greater than 0. N is right now how much? You are listening, right? N is how much? In the third iteration, n becomes 1. Are you following or not? Even you can do an year division for this also. So 1 greater than 0. 1 greater than 0. You can listen to me also. True or false? Now divide 1 by how much, guys? Divide 1 by 10. Okay. How many times it will go? 10 0 0. Yes or no? We don't have 0 point something, right? 0.1 is not there. This is integer division. Okay. 10 zeros 0. And what is remainder? Remainder 1. Finally, I got my, what did I get? I got my last digit from the number. I extracted 3 first, and then 2, and then 1. Finally, did we extract all the digits one by one or not? Usually in this logic, it happens from right to left. Maybe if you are curious how to do it from left to right, we will come to that point. First, let's have some basic understanding and actually the regular process, how it happens. Then later on, you can do in different ways. Got it right? Because that's how I learned programming. The same thing I'm trying to tell you, how it works. Okay. So, finally, what is your quotient, folks? 0 greater than 0. What do you think? True, false? No comment? Huh? False, right? Means iteration of loop stops. This is the logic. Almost all on this notepad, the whole logic is the whole program is there without syntax. That's a structure. Okay. You don't have a structure, but the whole program is there. So are you going to write this program now? Now write this program. Complete this. Fill in the program. No problem. I will write my code. Don't worry. You try it yourself. You can type your answer in the chat, dear friends who are online. Please give me your answer in the chat box. So you can also keep testing on dear friends who are online, because here I can see people working, but for you,
Last class I was also looking at notebooks.
okay guys, I am using idle again like yesterday. Somebody is asking me, sir, when we use this other IDs like PyCharm or Anaconda. Next week we will kickstart using any one of the IDs. Okay, is it fine? So now this is our idle, but for this basic programs, your interactive that Python prompt and idle is sufficient. But we are not going to stop with this. We come to all these different new IDs, everything. Okay, and how debugging happens, we'll learn that also. So one of the important feature in programming is debugging. You might write the best code, but at the same time you should know how to debug that code. That also we will learn. So this is our this thing. So what do you do right now? Take a number. Should I input from keyboard or should I directly? Then I am using a single statement this time today. Input of what is that? Enter n. This is just I am doing it in single one go, not like yesterday in multiple goes. Okay. So next one, input n. That is first thing. Second thing. So what else we need here? Once you input, this program is printing digit by digit. You don't need anything else. So you take a loop and write a condition while n greater than 0. While what greater than 0? You have idea about loop, right? Inside that, first extract reminder. How do you extract r equal to n percentile 10? Then that is what you should print. Whenever loop iterates, it will extract reminder and put it into R. First it will extract 3, put it into R. In the second iteration, it will extract 2, put it into R if it is 123. I'm just talking about 123. That's what we have analyzed. If it is 256, it will extract 6 first, put it into R. In the next iteration, it will extract 5, put it into R. Means your value of R keep changing, so print it immediately. Don't wait, because it's not a collection to add it. Might while doing collections, I'll give some interesting tasks to you. Preserve all this in the collection, all the reminders. Let's see how it goes like that. Okay, so print of what is that, gentleman? Print of R, then n equal to, what is that, folks? N/10. Say this, and this is what I'm just writing digit by digit. Okay, digit by. We had almost had a discussion of logic. Nothing to worry. You can do it yourself. Okay. I'm slow, very slow to this program, not because this is difficult, but make sure that you are very clear, because next programs you are going to solve most of the time. That's why I took time. This is very core and fundamental logic. Okay. Now let's run this. N123. You know the reason why it has given me so much out, so many iterations here, because I have to use double slash. I use single slash. That's why.
Right.
Okay, so you don't need to worry about it. If I am just giving you,
Can you define the difference between the single slash and double slash? What is in Python difference?
yeah, Ram. Actually, we had discussed that. I have uploaded that in the YouTube, but I'll just quickly tell you the difference. Okay.
Okay.
If it is yeah, you can mute it. If it is single slash, it gives you, it performs a decimal division. Decimal means if we are getting any the fractional part, it will take that. If you use double slash, it will take only it performs only integer division. It will exclude if any fractions are there. It is not going to take that fraction. It will truncate it and just take the whole number. That's all. That is the difference. To get more clarity, as I told you, I have clearly explained in our regular session. Maybe if you have some time after class, just go through that. But that is the difference. This performs, double slash performs, what is it, folks? Integer division. Means it will get quotient by doing integer operation. It doesn't give like usually when you are doing division 123. If you just say double slash, it will just take up to 12, not 12.3. If I say single slash, it will take 12.3. Got it right? That we all of us know. We had a discussion. So, okay. So that's about this one. Now you see this time you get a perfect output. I am closing and taking a fresh run window. I am giving 1, 2, 3 now. But this time I got this digit by digit 3, 2, 1. Suppose if I am using single slash, you might see it. You have to be careful what kind of division you are doing. If I do this, as you are not able to see due to this projector had switched off. Can you see this now? You might be wondering, sir, all my program is correct, everything is perfect, but I am getting something nonsense. See, if everything is correct, perfect, you get right answer only, right output. Means somewhere our logic is wrong. So where we have to go and correct it. So you have to correct it in the code here. If you do this, it will perfectly perform integer division for quotient. You can see here. Got it right? So my turn is over. I took some time. Usually for this program, spending half an hour is actually very bad, but still I spent it because to make sure you are very clear. Are you ready for next program? Let's do it. Come on. Write a program. From here onwards, questions are going to pour into your plate. Sum of the digits of a given number. You know how to find sum of first natural numbers, right? This time you have to do the sum of the digits. Suppose if it is 256, I should get 2 plus 5 plus 6. Don't worry. If you do 6 plus 5 plus 2 also, answer is same. Are you following this? So you don't need to worry about it. So now you try this. Do it now. Now you have to do the sum of the digits first. Okay. This is a small program. Okay. I'm just solving this because that program doesn't need that much time. Same program, take one sum variable. Should I initialize it to 0? Yes or no? Inside or outside? Sum 0. You got reminder. What I ask you to do? Sum of the digits. See, simple. You have to divide by 10 to get reminder. Again divide by 10 to get quotient. Operator differs. Okay. After you get extract reminder, what you have to do is write your logic. If not after reminder, you can write at the end also. I'm just keeping in an order, that's all. Once you understand the flow, it's not like you don't need to, you understand that you can keep statements, in any order, depends on the execution flow. So fine, that's fine. What should I do now? Sum equal to sum plus r. Earlier we used to do sum plus I. My remainder is in r. Then what should I do? I should say sum equal to sum plus r. Then print this sum outside the loop. We are done with this program. This is one of the, when we are doing this BTech or first semester, MCA first semester, graduation first semester. This is one of the very lab program, practical program. This is one fundamental lab practical program, which people think very difficult. Hardly we have 4 lines of code here. Okay, and if you observe carefully, what people keep saying is 10 lines or 100 lines in Java is 1 line is Python. Now if you observe carefully, are we writing the same logic here also? Except what is that you are missing out structure and declaration. That's all. Am I right or wrong? Almost what logic you write in C, in C++, Java, C Sharp, the same logic you are also writing here. You understand this point? Of course, Python has so much of stuff. You understand the power of Python when you move to the scientific packages and when you use APIs. Somebody is asking yesterday as APIs. Libraries, when you start using libraries, then you see the actual power of Python. But still, whatever you can do in Java or C or C++, almost the similar kind of code you can implement in Python. That's what I want to tell you. Okay, next one. Ready for next program? You know how to extract digit by digit, right? Suppose I have a digit like this. I'll just show you. Observe carefully. Or for someone who can't see, I have a number like this: 1, 2, 3, 4, 5, 6. What is my number? 1, 2, 3, 4. That is a big whole number. In that number, we are doing combinations. Now see, let's see how we understand now. If you have followed yesterday's session and till now today's session, then you understand how to apply all that. In that 1, 2, 3, 4, 5, print all the even digits. What do you have to print? You know how to check number is even, right? Now you apply the implementation. Now you are doing an implementation for yesterday's logics. This is a small implementation. Now you do it now. Write a program. What is that? To print even digits from the given number. What digits, sir? Are you following or not? Write a program to print even digits from a given number. Sir, you might think, you might expect some Python concepts. Don't worry. But before that, this is important. If you watch that movie Karate Kid, that who is that Jackie Chan? We will make that boy always practice that exercise with shut, and that boy gets irritated, bored, and frustrated. But still, you will make him to do that. You know why? Because for everything he says that is the foundation. Same thing here also. Print all the even digits. Today seems like there is a lot of power fluctuations. Not for online folks, for offline. We have a projector going and coming, going and coming. That's what. Are you done? I'll show you how we can apply our logic and how interesting it is if you understood that, and how boring it is if you don't understand. There are two faces of same coin. So what you have to do in the same program, you just need to print what numbers? Even digits. Iterate it, get the remainder first. That remainder is your value, right? R has your value. You know how to check whether number is even or not, right? You have to check that R, whether R is even or not. Okay, what do you do then? If R percentile 2 equal to 0, then what is that, folks? Print even, print R, exactly. Yes, correct only. We don't need even or odd here. We just need even digits. So print R. That's all, sir. Over. how to add one more condition check inside that iteration. Understood? Iteration in sense loop. So do I need sum this time? You don't need any sum. Sum is not necessary. Okay, you don't need sum because I just need what digits are even digits. So shall I run this code now? See here. Take some n 1 2 3 4 5 6. If not 1 2 3 4 5 6, take anything of your choice. Okay, did I get all the even digits from that number 642? Are you ready for another logic? Sum of even digits of a given number. One more logic. What is that? Sum of even digits of a given number. Next logic is a program to find, suppose 1 2 3 4 5 6 is there. Program to find sum of even digits of a given number. Okay, try this logic again. Do you have idea about prime and composite numbers? Yes or no? Next logic I'll give something. See how we can play with coding, you understand now. And you know perfect and non-perfect numbers also, right? Yes. You practice whatever I am asking you to do. I'm very sure tomorrow when you are working on some project, before going to check Google, first you look into these programs first for solutions. Trust me. Is it done? What do you do for this? It's a small correction. You need to make small changes to this code. First, you need sum here, as I say sum. And you know, I asked you to find sum of even digits. So you need this condition check, that is common sense. Now here, what you have to do is simply directly say sum equal to sum plus r. Inside that if, add that r. When r has even number, then only addition is performed. Otherwise, it is skipped from execution. Okay. And this is your incrementation. You might be wondering, where is incrementation for while? This time this acts as incrementation. Don't think incrementation always will be I equal to I plus 1, I equal to I plus 2, or I equal to I minus 1, something like that. Even this is also a kind of incrementation. You need to understand all these dynamics first. Okay. Shall I print this sum and continue to the next logic? On this model, I'll give one more logic and I'll switch to the next. Okay. So that you understand, once you understand the core logic buildings programs, then you get a clear picture how we can apply that again on top of certain things. Now we are doing that only. On top of yesterday's logics, we are applying today. Yes or no? Okay. So print sum and then go to the run and then say run module. Give some number. What I need is sum of 6 plus 4 plus 2, how much? I got 12 here. Okay, anyhow. You need to adjust for today. There is nothing we can do here.
It's not working.
So for today, you have to rest. Okay? Clear now? So that's it. This is about this. What did I do now? I have just modified the same code. You know how to extract R reminder. And then I put a condition check, a filter, which is whether it is even or not. And then done addition here, sum. And printed that. That's all. Next logic. Ready for next one? Next program is write a program. Continuation again. Write a program. Again, in that 1, 2, 3, or you can take any 6 or 8 digit number. In that print all, what numbers you are going to print? Print all even numbers. Sorry, print all prime numbers. You take some 6 digit or 8 digit number. Anything of your choice. You don't need to take my number. You can input whatever you want. Suppose I am using same example. You can choose whatever you want. Okay, I am taking up to 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. From that, what you have to do, folks? Write a program to print all. I think I'll write in Notepad. Okay, I'll write here. This is my number 1, 2, 3, 4, 5, 6, 7, 8. Program to print all. Program to print all prime numbers. Prime numbers from or prime digits from a given number. You can make it as prime digits from a given number. Prime digits from a given number. What you have to do first, get reminder. We have to use nested loop here. What you have to use? A loop inside loop. First get reminder. Again for that reminder you have to get factors. Yes or no? And based on you know how to find prime or not from yesterday's session. Okay, you try it yourself. Then I will explain it clearly. So until this point it is same for everyone. Until this R, extracting R. Once you extract R, you have to check first, find the factors of R. Of course, there are different ways to do prime number. To check how you do is your choice. I am doing in this way. Okay. Now you check find factors for R. Once you find factors for R, then what do you do? Then apply that condition check whether it is prime or not. That's all. And print the prime number. If it is prime, print it. That's all. Okay. And you have to use the loop inside loop. You need a nested loop this time. Don't hesitate. You can use one more loop inside loop. Next week, what we do is anyhow, we are almost what is that? We have got some almost covered the fundamental logics. We'll do a few more today and we'll close the session. Next week I'll start string. Actually, string is supposed to do this week, but as we are focusing on this logic building sessions, Okay. Shall I add it, folks? Okay. Shall I do it this code now? Is it sufficient for your time? Okay, guys, let me solve this. So first I should until this it is same. Now you should find factors for R. What should you do? How to find factors? We had a discussion. Let's see this now. So while what should I do now to find factors? Take one count. First of all, I need a count of factors here. Take one variable count. Initialize to 0 inside the loop, not outside the loop. Okay, you have to do it inside loop. After R, set count to 0. Then you write a loop here while what should I do now? I have to do an initialization also. 1 to that R, I have to keep iterating that loop. Yesterday we had discussion, right? What is that? 1 to R. I'm explaining the same thing. So you take one loop variable here, initialize to 1, and then what is that? I less than or equal to R. Okay. What should we do? I less than or equal to R. Then here inside loop, what I have to do? If R percentile I equal to 0, colon, then what should I say? I should increment count. Count equal to count plus 1. Are you following or not? Okay, you can see on the projector here. Now increment increment your loop I equal to I plus 1. Then after loop, put a condition check. What is that? I should print just even prime numbers, right? If count is 2, if count equal to 2, then you should print what? You should print that R, because that is what is a prime number if it is satisfying this condition. Print R. Okay. So that's all. This is what the program is. Logic is this. Might be, let me cross check if anything is there. If you see here, this part from here, whatever we have done yesterday, we are repeating it. Rest of the code is same. What is that? Getting that reminder and then incrementing this loop. That is same. Outer loop I am saying. Now again, you put a, what is that? A loop internally. Put an inner loop. Okay. And then what you do for inner loop? you iterate it from 1 to that number r remainder. If r is 7, iterate up to 7. If r is 6, iterate up to 6. If r is 5, iterate up to 5. Get the count of factors first. What do you need? Get the count of factors. Whenever you are checking for prime, you should get factors count. If it is perfect, you should get sum of factors. Now finally let me run this. How many digits I should get if it is a 8 digit number? I am giving a simple 1 2 3 4 5 6 7 8. 7 5 3 2 0. 7 is good, 5 is good, 3 is good, 2 is good, but 0 is bad. Yes or no? Why should we get 0? I'll just check somewhere. Yeah, I am printing some, otherwise it's perfect. Clear, right? Go to the run module. Otherwise I will close and take a fresh window so that you can see the. So if you see this 1 2 3 4 5 6 7 8, perfect. Are all these are prime numbers? 7 5 3 2, are this prime or not? That's it. Now from this number I have extracted all the prime numbers. On top of this again you can do a logic. What is that logic? Again sum of prime numbers you can do. You got it right? So you can, in this way you can do what is that logic inside logic, logic inside logic. Are you following or not? That's how you can play with programming. Do you want to do this program again? Inside a number you have extracted all the digits.
Yes.
From that you have verified whether it is prime or not. Again after verifying prime, again what I need is the sum of all primes. That is one logic. You got it right? Like that you can keep on nesting your logics. Got it right? So that is the program. Just observe it. You can see here when I run this, because you didn't see the execution, I'm just running one more time. Last time 1 2 3 4 5 6 7 8, enter. Got it right? So I'm stopping this kind of what is that, it keeps going. Understood? I can keep on giving this kind of this thing, but it's enough. There is no ending for logic sessions. But now I'm going to take one more, last one, not this one. I'm moving to the next logic now. Sum of cubes of digits. You have done sum of digits. Sum of squares you can do, sum of cubes. Next logic. Let's continue. Let's come out of this this thing now. Are you clear with what we are doing right now? Yeah, it's possible. Why not? It's always possible. So this is actually finding what, until this it's clear. Getting up to reminder, it's fine. So after getting reminder, what I am asking, I'm asking you to print all the prime numbers, whether that r is a prime or not. The requirement is simple. You have a number, in that you need to print all prime digits. When you are doing that, first get each digit into the remainder, check whether that r is prime or not, and print it. That is the simple. So now what I am doing, I am using a loop here. Are you following or not? In that, did you have code with you? You can see. When I set count to 0 because first I need to get count of factors to check whether it is prime or not, because prime has just 2 factors. Based on that condition, I am following. Okay. So now I am iterating from 1 to r, 1 to that r. Suppose r has 8, then loop has to iterate for 8 times. R has 7, loop should iterate for 7 times. Then check whether that from 1 to that number, every digit divides this r or not. If it is dividing, it is a factor, then count it, increment count. If it is not, skip it. Then after that, at the end, outside this loop, check whether count is 2. If count is 2, then it is a prime number. If it is more than 2 or less than 2, it might be composite or neither prime nor composite. You understand? Okay. Still, if you have a doubt, you can ask me after session. Next program, sum of cubes of digits of a number. So what is that? Sum of cubes. Now we have done sum of digits. Sum of cubes of digits means what? It is something like this. 153 is there. It is like 1 cube plus 5 cube plus 3 cube. Okay, means you can do from back also. 3 cube plus 5 cube plus 1 cube is same. You don't worry about the order. You do from back to front or front to back, is that's not an issue in addition or doing product. That doesn't change. Same thing, you know how to find sum of digits. Sum of cubes means you have to do it now. And this will slowly leads to Armstrong. Now we are at the doorstep of Armstrong. Now we will step into the Armstrong. If you put one more step inside, it will be Armstrong. If any of your friends were interested, you can bring them also to sessions. Okay, no problem. You don't need if any issues there, you tell me. I'll talk to them. Okay, guys. This is not something too difficult logic. Sum of cubes in sense it's something like this. Take a number n. Same thing, that R concept is same, but you don't need too many statements this time. Even you don't need count this time. Might be some variable is required because as we are doing sum equal to sum plus. Earlier we have done sum plus R for adding one digit. This time what I need, sum of cubes. Cubes means what should I do? R cube, R into R into R. 1 cube means 1 into 1 into 1. Got it right? So it is R into R into R. Okay. This Armstrong logic changes depends on number of digits. If I remember, for 3 digits it's in R cube. We have to do the cubes. For 4 digits you have to do the power of 4, I hope. For 5 digits you should do power of 5. Like that Armstrong differs. Okay. You can try the remaining versions also. I'm giving you 3-digited version of Armstrong. 4-digited you have to do to the power of 4s. 5 digits power of 5, something like that. Check it once. Check the problem there, problem statement. So what this is about cubes of a number. I'll print it. Print of sum. And then number I'm giving 153 for testing purpose. I get 153. That's an Armstrong number actually. We'll check it. Are you good now? Do you understand this doing sum of cubes? This is not something difficult logic, it's easy logic. Next one, write a program to check whether a number is Armstrong or not. program to check whether number is a Do you have anybody from China or what? Okay.
So we can directly put two powers, no? Like 2 stars and then.
No, for this program we need like this. Okay. We'll talk after class. I'll tell you what to do. Okay, guys. To check Armstrong, what should you put an if else? But before doing that, what you have to do? Preserve your value of n. What do you have to do? Because by the time you complete your iteration, on 1 minute, just listen to my point. So here you have to preserve n. Okay. So anyhow, you have observed, right? By the time you finish the iteration, n becomes 0, yes or no? Initially, suppose you take a 3-digit number. You can take 256. Initially, it is 6. We extracted 6. After that, 5. After that, 2. By the end of iteration, n becomes 0. What is there in n? N has 0. N doesn't have 256. Because every time you modified n, first time 256, second time 25, third time 2, fourth time 0. Most of it, when you are doing this for the first time, you don't remember that n became 0. This mistake most of the students do in the very first time. Even we have done it. I have done it also. So what should do right now? First, preserve the 10 to some variable. Say some temp equal to n. If not temp, you can take t. That's your choice. I'm not restricting to what variables you should use. Then after that, you have to do a condition check now. Actually, your value is there in which one? Temp or n? Your original value is there in temp. N will get modified, right? What do you have to do? What is an Armstrong? First of all, do you know what is Armstrong? If sum of cubes of digits of a number, 1 cube plus 5 cube plus 3 cube is equal to the given number. 1 cube 153, take, extract each digit, do the cube of every digit. And again, if that sum of cubes of digit is equal to the actual number, is equal to the given number, is equal to given number, it is Armstrong. You take 153 best example. Hardly in first 1000 you have some 2 or 3 Armstrongs, that's all. 1 cube plus 5 cube plus 3 cube, how much? You get 153 only. That is an Armstrong number. Means now you have found sum of the cubes of digits. What did you do? You found sum of cubes of digits. If sum equal to, should I compare with the n or should I compare with temp? I have to compare with temp here. I should not compare with n because by the end of iteration n becomes 0. I have explained that here. You see in the notepad also, by the time you complete all iterations n has 0. So if sum equal to temp, then it is what? Armstrong. Okay. Else what, gentlemen? Else printer? Not Armstrong. Okay. Are you following or not? There's nothing. If you have followed yesterday's logics, today's the very beginning session logics, then you can automatically solve all this. This is Armstrong. But initially what happens is most of the students don't preserve this n into some variable. Before you do this iteration, preserve that. Not in the middle or not at the end. Before you begin iteration, store the value of n into some variable. Now run this. I give 156 because that is the very basic Armstrong. It is Armstrong. Give 256. It's not Armstrong. Perfect. Okay. Are you good now? Ready for next logic? Program to reverse a given number. Try that now. Anybody has still any issues here? Program to reverse a given number. Yes. Keep doing the coding. Next program. Program to reverse a number, reversing a number. Suppose if I have 123, you should make it as 321. Anything. It's not like you should take 1, 2, 3. We have almost solved all the BTech first year lab programs. Maybe if you didn't do when you are in BTech, then you have done it now. How do you reverse a number? It's very simple, folks. If you are new to this logic, already you know how to find sum of digits, right? Small addition to that gives you reversing a number. Sum equal to sum plus r. Keep it like that. I'll just explain in the most easiest way to understand, remember or understand it. You should not remember logic. You should understand it. Until this point, it is same, guys. Reversing until this point, except there is a small change you have to do to this logic. Reversing a number means if you have, suppose you take an example of anything of your choice like 126. What it should be, it become 621. You divide with 10, you get some, you extract some digit. In school days, we learned this. Our maths teacher should have told us. If you want to reverse a number, when you divide it with 10, you multiply with 10. Somewhere your maths teacher told this, if you remember. Maybe you forgot it. If you divide by 10, to reverse it, you have to multiply by 10. What do you have to do? Multiply by 10. Whatever number you extract, that you should multiply by 10 and add it to the remainder, next number. Multiply by 10, add it to the next number. Multiply by 10, add it to the next number. Actually, our number is r, isn't it, or not? But what we do, we keep it into sum first. We put it into sum or not. Sum equal to sum plus means initially 0 plus r, how much? Sum is 0, right? 0 plus, suppose 6, how much? 6. Now 6 is there in sum or not? Don't say r into 10. You have to say sum into 10 plus r. Are you following what I am trying to tell? Your r is actually added to sum that has actually your r. Your logic is simple. Sum into 10 plus r. This will reverse your number. Are you following or not? The point is simple. Take the number into 10 and add it to the next remainder. That is the logic. Why should we do this product? I told you just now. Our maths teacher told this, not me or somebody else. It's a mathematical thing. If you are dividing it and getting a digit, and if you want to reverse it, again multiply it. Got it right? So this gives you reversing of a number. That is one thing. Try this now. A small change to the sum of digits gives you reversing a number. Following or not? Okay. So just print that sum. Maybe if you are little, if you think that it's important to follow some standard convention, naming standards, instead of sum you can put REV also. What do you have to do? Put the REV or reverse or something, a meaningful name you can give to your variable, okay? But that reverse has to set to 0 in the beginning, same like that sum only. Guys, are you good now? Put REV here. For now I am removing this. Again we'll come back for a palindrome. Palindrome is almost done. Logic is this. Let me run this first. Then we'll come back to palindrome thing. Invalid syntax. What's missing? Okay, this is actually CPP comment or Java comment, double slash. I have to put a hash for which comment, or I have to use triple quote. 126 621. Perfect. Give 1 to 1. What do you get? 1 to 1 only. That's palindrome. Ready for next program? Next program. I think we are almost running out of battery. Unfortunately, I forgot my battery today. After this, we'll stop this session. Palindrome means you take a number, reverse it. This is reversing. You understood how to reverse, right? If a number reversed is equal to the actual number, 1 to 1 palindrome. Okay, 5 to 5 palindrome, like that. So what you have to do, put a condition check. But before you do this, preserve your original number in some temp variable, same like Armstrong. Put a if else here. What do you have to do? Put an if else. So here, what do you have to test here? If your temp equal to REV or REV equal to temp, anything is fine. Then it is a palindrome. Okay, it's a palindrome. Else it is a not palindrome. Now run this number. Almost the logic is there. You know how to reverse now. You understood this. And then what is that? Checking whether it is palindrome or not. Put this condition check, a filter here, apply a filter. If your temp is reverse, then your original number, reverse number are same. 1 to 1. Pal means palindrome. Again, 1 2 3. No doubt this is not a palindrome. Got it right? Okay, that's about palindrome thing. Okay, are you good now? You take 1 to 1, reverse it. What do you get?
10,
1 to 1, reverse it.
1,
1 to 121, reverse 121.
121.
That is palindrome. You reverse madam, MADAM, madam. Madam, that is palindrome, string palindrome that we do in strings. If you take a number and reverse it, if you get the same number, it is a palindrome. Okay. Did you finish this, folks? All of you are good now? Guys, I think today we are going to stop here because unfortunately I forget my charger today. Otherwise, I would have continued up to 12:30. But still, we'll continue. In the next class, I am going to start with strings and do as many programs as possible on string. At least 15 to 20 programs we do in a session. At least. So, how much our time it will continuously will be doing coding only. Topic examples, topic program, topic program. That's how it goes like that. Clear now? This logics again we are going to again this is going to recycle in this cycle will come again in collections. Now at that time you understand. Okay, this guy had make us
What happened? What happened, sir?
Are you there, sir?
There, are you there? Sir, are you here?
I hope this session is over.
Hey, Raghu. The meeting is over.
I hope this session is over. I'm going to disconnect.
Sir, are you here?